what are you looking at?
Well, I'm looking at the world map. It made me curious if all the continents were just one big land, then it all separated due to time.
Ooh, that's interesting. Have you heard about the Pangea?
Huh? Panji... What?
It is pronounced Pangea. It means all Earth. It is believed to be a supercontinent that was formed around 300 million to 200 million years ago. It is a huge landmass composed of 7 continents that we have today.
Yeah, that supercontinent was surrounded by a single ocean called Pantalasa.
Hey guys, what are you talking about?
We are talking about Pangea. Have you heard about it? It's so cool.
Yes, I heard about it. Pangaea first broke out into 2 subcontinents.
Yeah, Laurasia in the north and Gondwanaland in the south.
We have overheard your conversation. Did you know the idea that all continents that we have today were once a huge landmass was explained by Alfred Wegener in the early 20th century? Wegener proposes continental drift theory and explained that about 300 million to 200 million years ago, the continents were once part of a one large landmass.
Oh, that is impressive.
Yeah, but do you know what a continental drift theory is?
What is it?
Well, continental drift theory is one of the earliest ways geologists thought continents moved over time. It explains how continents drifted away from each other over the course of geological time.
Correct. Also, a fun fact, scientists at the time of Alfred Wegener did not agree and accept his theory. He was ridiculed for the idea that continents were adrift, though most of the pieces of evidence for his theory, such as geographic fit, fossils, rocks, and glacial deposits were correct. One of the major setbacks of his theory is his inability to provide an explanation of how continents move around the planet.
According to my research, his explanation for the continents movement was disproved by scientists. For instance, Wegener thought that the continents might have flowed through the ocean crust like icebreakers smashing through ice. The physicists explained that the ocean crust is too strong for continents to flow through it, and the frictional resistance is too great for continents to slide over oceanic crust.
Okay, Mr. and Miss Smarty Pants. Calm down a bit.
So that explains the continental drift theory. It's crazy, right?
So what are you thinking about now, Andrea?
Well, do the scientists actually believe Wegener's theory over time?
That made me remember a topic in school. Another fun fact, when the scientists study ocean floor, they found a system of ridges or mountains in the seafloor like those found within the continents.
I think I remember what you are saying. Those are called mid-ocean ridges. One of these famous mid-Atlantic ridge is an undersea mountain chain in Atlantic Ocean. It has a massive crack about 32 to 48 kilometers long and 1.6 kilometers deep. The ridge is offset by the fracture zones or reef valleys.
Of course you remember, Angel. We are in the same class. But anyways, let's get to the point. In early 1960s, American geophysicists Harry Hess and Robert Deeds proposed the new oceanic crust was formed along the mid-ocean ridges between the 2 continents.
Also, Hess cautiously studied maps of the mid-ocean ridge system. He began to think about the ocean floor in relation to the problem of the continental drift. He reached a startling conclusion. Perhaps Wegener was right about when he said the continents do move.
Ooh, what did he discover?
Harry's hypothesis that mantle material from the mantle of the Earth constantly moves out along the mid-ocean ridge. As the magma cools down, it is pushed away from the ridge. We call it process seafloor spreading.
Wow, this is amazing. We get to brainstorm on what we know. Let's continue. This is getting interesting.
Can someone please elaborate seafloor spreading?
Might as well share something, Jampol.
Sure, lads. In seafloor spreading, the seafloor spreads away from each other on both sides of the mid-ocean ridge and new crust is being formed. The spreading of the seafloor creates a successive
Correct me if I'm wrong. So over time, the new oceanic crust pushes the old oceanic crust slowly away from mid-ocean ridge. As it moves, it becomes cooler, denser, and thicker. Eventually, older oceanic crust encounters a tectonic boundary with a continental crust or another oceanic crust.
That is right. In addition, in a place where two oceanic plates collide, or when an ocean plate and a continental plate collide, a subduction zone occurs. As the new seafloors form at the mid-ocean ridge, the old seafloor farthest from the ridge is destroyed at the subduction zone.
Seafloor spreading also allows the creation of new bodies of water. Anyone who can give an example?
Me! The Red Sea, for example, was created as the African plate and the Arabian plate moved away from each other. It is also pulling the continents of Australia, South America, and Antarctica separately in the East Pacific rise. One of the most active sites of the seafloor spreading is the East Pacific rise, spreading at 14 cm yearly.
Brilliant, marvelous, amazing.
Thanks for watching. Cheerio, ciao, adios.